Estimate the slope of the tangent line to f of x equals negative x squared plus 4 at x equals 1 using a few secant line slopes near x equals 1. While not strictly necessary, sketching a graph of the function can be helpful in getting a rough idea of what the answer should be and for visualizing what exactly it is that we're being asked to do. The graph of f of x equals negative x squared plus 4 is a parabola opening down, since the coefficient on x squared is negative, that has been shifted up 4 units, putting the vertex at the point 0, 4 on the y-axis. Now I could draw this by hand, but I want the picture to look nice for you, so I used a computer to generate it. When x equals 1, y equals f of 1, which is negative 1 squared plus 4, which is 3. So we're looking for the slope of the tangent line at the point 1, 3. We can sketch the tangent line and maybe even draw it well enough to use the sketch to estimate the slope, but that's not what the problem asked us to do. Instead, I'll sketch the tangent line just to show that its slope is negative and looks to be around negative 2. To estimate using secant line slopes, we just need to pick a few intervals to look at. You can do whatever you want, but the closer the second point is to the point 1, 3, the more accurate your estimates will be. I'll choose to use the secant line from x equals 1 to x equals 2, then the secant line from x equals 1 to x equals 1.5, and finally the secant line from x equals 1 to x equals 1.01. It's worth mentioning that even though I'm choosing secant lines where the second point is to the right of the point 1, 3, this is not at all a requirement. You could use the secant line from x equals 0.9 to x equals 1 if you wanted. I'm just choosing points to the right because I know that will mean the denominators of my slopes will be positive. For the secant line from x equals 1 to x equals 2, to find the slope, I need the y-coordinate of the second point, which I can find by evaluating the function at the second x-coordinate. It's pretty clear from the graph that it's going to be 0, but just for practice, let's evaluate it. F of 2 is negative 2 squared plus 4, which equals negative 4 plus 4, which equals 0. Now that I have both points, 1, 3, and 2, 0, I can use the slope formula, which, remember, is the same as the average rate of change formula, y2 minus y1 over x2 minus x1, which is 0 minus 3 over 2 minus 1, which is negative 3 over 1, so negative 3. This slope is negative, like expected, but we can see from the graph that this secant line is significantly steeper than the tangent line. For the secant line from x equals 1 to x equals 1.5, again, I need the y-coordinate of the second point. F of 1.5 is negative 1.5 squared plus 4, which is negative 2.25 plus 4, which equals 1.75. So the slope of this secant line is 1.75 minus 3 over 1.5 minus 1, which equals negative 1.25 over 0.5, which equals negative 2.5. Finally, let's look at the secant line from x equals 1 to x equals 1.01. The last two secant line slopes were very rough estimates because the points were so far apart. This estimate should be much better because the x-coordinates are only 0.01 apart. F of 1.01 equals negative 1.01 squared plus 4, which is negative 1.0201 plus 4, which is 2.9799. So the slope of this secant line is 2.9799 minus 3 over 1.01 minus 1, which is negative 0.0201 over 0.01, which is negative 2.01. We could keep going, but it seems like our guess that the tangent line slope was negative 2 is accurate. There's no way to know for sure just by testing secant lines. To truly calculate the tangent line slope, we need to look at the limit as the distance between the two x coordinates goes to 0. We won't actually do that here, but that's where we're headed.